In this lesson, I'm going to teach you how to divide a polynomial by a binomial using synthetic division. Now, synthetic division is a little more efficient than long division. It also doesn't contend with all those variables that you have in long division. So let's get started. The first step, just like in long division, is to make sure the polynomial is written in descending order by degree. So here's my division statement. This is my polynomial and this is my divisor. Okay, so if we're looking at p of x, which is our polynomial, we need to make sure the polynomial is written in descending order by degree. It looks like it is because the first term has a degree of 3, the one that follows is 2, and the next one has a degree of 1, and lastly the constant has a degree of 0. So we are good to go. Now we set it up the synthetic division as follows. So start with a upside down division bar. What goes inside the upside down division bar are the coefficients of your polynomial. So in this case, we have a positive 2, a positive 5, a negative 2, and a positive 4. There you go. Now we need to find the number that goes in front of the division bar. Now that number is going to correspond to the root of your divisor. So to find the root of your divisor, set it equal to 0, x plus 3 is equal to 0, and solve for x. And the root is going to be, in this case, x is equal to negative 3. So that's the number that goes right in front of your synthetic division bar. Okay, now we carry out the synthetic division as follows. First step is to bring down the first term inside the bar, which in this case is 2. Then you're going to multiply the 2 by the negative 3 in front, and that's going to go right underneath the 5. In this case, it's going to be a negative 6. Now you have to add the 5 and the negative 6 together, and that's going to give you a negative 1. That goes right underneath the division bar. Now you're going to take that negative 1 and you're going to multiply that negative 1 by negative 3, and that's going to go underneath the negative 2. In this case, it's going to be a positive 3. Now you're going to add negative 2 plus a positive 3 gives you a positive 1. Okay, and now we're going to multiply this 1 by the negative 3 in front, and that's going to give me the next number, which is negative 3, and that goes underneath your 4. Now you need to just add the 4 and the negative 3, and we get a positive 1. So that's how you do carry out the synthetic division. Now we need to take a look at the numbers that we produced in the bottom row. This last number here is going to represent your remainder. So once we divided, we find that we have a remainder of 1. Now these three numbers, on the other case, represent the coefficients of our quotient. So if I was to write our quotient, which we will denote as q of x, it will have the quotients of 2, negative 1, and 1. But how do we find the powers of each of these terms? Well, take a look at your polynomial. In this case, it's right up here. The degree of this polynomial is a 3, okay? And so the quotient is going to be uh, one less than the degree of your polynomial. So the degree of our quotient here is going to be a degree of 2. Once we know that, we can write our terms. So our first term is going to be a 2, which came from the first number of the bottom row. That degree of that term is going to be an x squared. Now we write the second term, which is a negative 1x, and the degree of this term is going to be 1 less than the first term. In this case, it is 1. And then the last term is going to correspond to this 1 right here. So it's going to be a plus 1, and the degree of this term is going to be 0. But any number raised to the power of 0 gives me a 1. So you don't need to put that in there because 1 times a 1 will just give you a 1. So we can just write it out like that. And also, you don't need to write the 1 right here in the middle term. You can just erase that if you'd like. And so your result, your quotient, is represented by this quadratic 2x squared minus x plus 1. There you go. So, the last part of my question here is to rewrite my polynomial in this form, which should be quite familiar with already. So, our answer or our division statement is as follow. P of x is equal to our divisor. So, in this case, it's x plus 3 times our quotient. So, our quotient is right here, and it's 2x squared minus 1x plus 1, and we're going to add our remainder. In this case, the remainder we found was to be 1. So there is the division statement of our division question. There you go. So let's take a look at my next question here. This one's a little different. This is where we need to find, so we have to use a 0 placeholder. So let's take a look at what we have here. We have our polynomial, so this is p of x, and we have our divisor, which is a binomial. So you need to check once again, make sure your terms are written in descending order by degree. The first term has a degree of 4, second term has a degree of 2, third term has a degree of 1. Okay, so it is in descending order by degree, but it looks like we are missing a few terms here. So you have to use 0 as a placeholder. So if I was to rewrite this polynomial here, we have to substitute a power of 3, and we use a product of 0 to do that. So x is to the power of 3, that's our next term. And now we have a second degree term, which we have is negative 5x squared. Next term is a degree of 1, so 12x. And then lastly, we are missing our constant. So we still have to add 0 to make up for the fact that we don't have a constant for this polynomial. So there you go. That's how you rewrite our polynomial so that all the powers are there. So use 0 as a placeholder. Now we carry out the synthetic division. Start with your upside down division bar. The numbers that go inside are once again your coefficients of your polynomial. In this case we have 5 of them, so 3, 0, negative 5, 12, and finally 0. Now the number that goes in front of your division bar is the root of your divisor. To find the root, you go x plus 1 is equal to 0, and the root is negative 1. So that's the number that goes right in front of your synthetic division bar. Okay, so let's carry out the synthetic division. Bring down the 3, multiply the positive 3 by negative 1, and that gives you a negative 3. Now you're going to add 0 plus negative 3, which gives you a negative 3. You're going to multiply that negative 3 by negative 1, which gives you a positive 3 that goes underneath the negative 5. Now you're going to add the negative 5 and the positive 3, and that's going to give you a negative 2. Now you're going to take that negative 2, you're going to multiply it by negative 1. That's going to give you positive 2. And then you're going to add 12 plus 2, and that's giving you 14. Then you're going to take that 14, multiply it by negative 1, gives you a negative 14. And 0 plus a negative 14 gives you a negative 14. Okay, so let's take a look at the last row on my synthetic division here. This is the last term is your remainder. So we have a remainder of negative 14. And these 4 numbers are going to represent the coefficient of our quotient. So if we write our quotient out, it's going to be 1 less the degree of the polynomial here. Now the degree of this polynomial is 4. So we know the quotient has to be 1 less than that, which is degree of 3. So to write this out, we start with the first term, which is the first term of our last row, 3x to the power of 3. Then you're going to subtract the second term. That's where the negative 3 comes from, right there. And that power of that term is going to be 2. So we're going down in degrees. Next term is going to have a degree of 1, and that coefficient's a negative 2. And finally, our constant is going to be a positive 14. So there is my quotient. Now I want to write my division statement out, And that will be it. So p of x is equal to the divisor, which is, let me go back to make sure this is right, x plus 1 times the quotient, which is right here, 3x cubed minus 3x squared minus 2x plus 14. And you're going to add the remainder, which is negative 14. Actually, instead of adding a negative 14, I'm just going to go straight out minus 14. And that is the division statement for this example. And that's how you synthetically divide a polynomial by a binomial.